Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And in studio with us we have Paige. And Paige, if somebody needed to get a hold of us, what would they need to do?
For math homework, help call in Bakersfield 636-4357, toll free 1-866-366284. Email dothemathonline.net. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, there you go. A lot of ways to get a hold of us, aren't there? Mm-hmm. All right, before we get going, why don't you let everybody know where you go to school and what grade you're in?
I go to school at Hart Elementary, and I am in 6th grade.
How's 6th grade going?
It's going okay. Social distancing isn't the best.
Right, yeah, well, we kind of got used to it at the end of last year, and so far we're getting through it. Is it a little bit easier now in 6th grade than it was at the end of 5th grade?
It is easier, but it's not like I like it that way.
Yeah, I don't think anybody really likes it that way. Right? Occasionally there are some students and they go, yeah, I kind of like it because they like working on their own a little bit. Mm-hmm. But I'm sure you miss seeing all of your friends and things like that a lot. Are there any activities that you do, like band or chorus or anything like that?
Yeah, I do band and chorus.
Okay, so how does that go doing it virtually?
So we have, for band, we have Zoom twice a week, and that actually has gone pretty decent. But for chorus, we have it once a week, and not everyone shows up, but...
That must be hard, the chorus thing.
Yeah. Getting
everybody together on different Zooms and doing that kind of a thing. I would think that would probably be the most difficult, because I know sometimes at the end of the day, I'll be with my students and I'll go, hey, everybody on the count of 3, let's say au revoir, and it doesn't come out all together at the same time. So I can just imagine what singing would do, because there's a lot of kids in chorus too, right?
Yeah.
Yeah, there's a whole lot. All right, well, you know what? We certainly are glad that you're here. You ready to do a little math in a little bit?
Yes.
All right, well, before we get to that, we've got an extra special bonus going on starting today. Do you have any idea what it is?
No.
Have you ever been to Holiday Lights at Com?
Yes, I did.
Well, good. Well, you know what? Check this out.
Holiday Lights is back for its 18th year in a way to keep you safe and socially distant. This year, Holiday Lights at Com, presented by Dignity Health, lets you drive through millions of lights and colorful displays from the comfort of your car. Tickets must be purchased in advance online at comzoo.org or in person at any Valley Strong Credit Union branch and at the Com gift shop. See Holiday Lights between Lake Ming and Hart Park on Alfred Harrell Highway and follow the signs. See you there.
And that's right, Holiday Lights at Com, a family tradition been going on for a long time, will continue. Even though the virus and things are around, not going to stop Holiday Lights at Com. So that is going as strong as ever, a little different this year. But if you're out there watching right now and you would like a free ticket to Holiday Lights at Com, all you have to do is give us a call sometime today. If we do your problem on air, then you will receive a ticket. And I believe the ticket is good for a car full of people. So it's not like just the student gets the ticket, the car full of people get the ticket. So if you would like a free ticket to Holiday Lights at Com, all you have to do is give us a call today or tomorrow. Today is the 17th of November. So we have today, we have tomorrow, and then we also have after Thanksgiving, the first 2 weeks in December also. So any of those days you can win. Once you win once though, you've won, and we're gonna move on to some other people, get as many people out there as we can to enjoy those holiday lights. So Before we get to all of that and we start putting Paige to work, it is time now for today's Math in the News. All right, today's Math in the News, we are fortunate enough to have Tiara King from Junior League of Bakersfield in studio with us today. And Tiara, thank you first of all for coming in today.
Thank you for having me.
First of all, there are some students and there are some that have watched for a couple of years, and Junior League has been a partner with Do the Math for a number of years. But for the new viewers and people that may not remember, what does Junior League do?
So Junior League is an organization committed to community and committed to developing the potential of women. So we serve our community through effective leadership and getting our girls out there, getting our Junior League members out there to just dive into our community and support and surround them in any way we can.
Okay, and this is a national organization.
That's correct.
And I know that you guys have, I'm trying, not meetings, but where you go and
Yes,
meet
conferences.
with other, I don't know why that word was escaping me for a moment there.
That's right.
But anyway, where you learn from other leagues around the country.
Yes.
Now, how long have you been with Junior League?
So I've been with Junior League for 3 going on 4 years. It's been amazing. I got involved initially because I just wanted to kind of come together with like-minded individuals and figure out different ways in which I can become involved, and they develop the potential of women, and in doing so, the networking, the different skills that we learn, that really sparked my interest and I became a member.
How many members are there in the local?
Locally here in Bakersfield, our membership is about 300. We have some that are sustainers and then we have some that are actives. Altogether, it makes up about 300 members.
Okay, and you are going into your 4th year.
That's right.
And you have a position coming up where you are the president-elect.
That's correct.
And I know that a lot of students understand the term president-elect now,
Yes.
but what does that mean for you?
For me, president-elect is really, this year has been tremendously understanding where we've been, where we're going, and supporting the current president in everything that has been going on, just kind of being her support system and backbone, and then learning everything that I can about the background of Junior League. So all of the administrative, operational things, and really diving into different committees.
And it certainly is a lot going on
a
with
lot.
Junior League. What are some, because Junior League has been a supporter of Do the Math in the past,
That's
and they've been a great friend of the show. What are some of the things that Junior League does that benefits students?
So I know last year and before COVID, we were really out there engaging with youth and with children. I don't know if you guys have heard of Holiday Cottage, just because it's coming up on Christmas. So yes, we used to get out there and get to hand out those different gifts and support Holiday Cottage. We've also, since COVID, we've done book drives. We're currently working with the Quiet Book Queen. It's a program to produce quiet books, the soft books for reading. Our focus going into next year, we're gonna dig deep into reading, supporting the different organizations as well as the different students who are interested in reading, want to learn more about literacy or have questions.
All right, well, you know what? How old does somebody have to be? Like, could Paige get into Junior League?
18 and older.
18, all right, well, because she might be like, hey, this, I want to start getting into stuff like that. So once a lady is 18, and does it take a while to actually get into Junior League? And what happens once they get in Junior League?
It takes about, well, the first year is what we call like the introduction year. And so it doesn't really take a while to sign on, but you do take that first year to really learn about Junior League, learn about the women and where we're going, the different committees and what our goals are and objectives. And then after that year, you move into being an active.
All right, and you have a lot of actives right now.
Yes.
All right, well, certainly do thank you for coming in today, Tiara, to talk to us a little bit about Junior League of Bakersfield and the different things that you guys do that help support students in Bakersfield and Kern County, all over the county, right?
Yes.
All right. Well, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, and in case you missed the beginning of the program, if you phone in to do the math and we do one of your math problems on TV, you will automatically win yourself a ticket to Holiday Lights at Com, and it's, well, I win a ticket. Well, it's a ticket for a whole carload of people. So that's the difference between this year and years in the past. So in studio, we have 6th grade student from Hart, Paige. And are you ready to get to work?
Yes, I am.
Over to the board, young lady. Here we go. So I know that you've been working on multiplying fractions. So let's take a look at this one. Here's one we have. 4 over 5
Okay. 4 over 5.
times 3 over 8.
Okay.
And explain how you would do that problem, and if you know any shortcuts or anything like that to make it a little easier.
Okay, so what I would do is I know that these two can be divided smaller because they have like a common factor. So I will cross this one out, and I can divide these both by 4. So this would become a 1, and this one would become a 2. And these are not divisible by each other. So I would just multiply this straight across, unless I did this wrong. 4 tenths, and then I would have to simplify that.
So check your top, because it's multiplication you accidentally added. So you have the 1 where you crossed out the 4?
Yeah, I see this. So that would actually be 3 over 10. And then that's my answer.
All right, now you were saying if you were doing it right.
Yeah.
How do you think, is there anything that you were looking at that might have made you think that you may have not been doing it right?
Yeah, because when I had this answer as 4 tenths, I thought maybe that one of these had been wrong. And so I was going to simplify that, and then she caught my mistake.
There you go. All right, good. Well, erase that problem. I've got another
Okay.
one for you right now. So let's try something with a whole number in it.
Okay.
1 over 14
Okay.
times 28. And explain what you need to do now.
So because this is a whole number, I'm going to put a 1 under it. And I know that these two can be smaller. So I'm going to cross this out. And I'm going to actually divide them by 14. And I'm going to get a 2 and a 1 here, which my answer would then be 2 over 1, which is also 2 wholes.
There you go. Nicely done. So you didn't even need any of Cindy's help on that one, did you? No. All right, erase the board, young lady. You're on a roll, which means we need to step it up a bit. All right, here we go. So you're going to want to start over on the left now this time, because this is going to be a little longer for you. 3 over 4
Okay.
times 1 over 3
Okay.
times 2 over 5.
All right.
If you need help, Sydney's right there.
I'm going to do this the way I know how to do this. And so for me right now, I'm going to multiply straight across on this one. And I'm going to get 7 over 60.
Okay, look at
That
your top.
numerator messes you up, because it did on one of the other problems. So
Oh,
work
it's
with
6
Cindy real
again.
quick.
Yeah. You accidentally keep adding the 1.
Yes, I do.
Yeah.
And then I can divide this by 6, and I could get a 1 and a 10.
Okay, good. Now let's just talk, just because you know, you just went straight across and didn't cross cancel like you were on the other ones. So you can still use that method here. If you look like at these two, you could cross the 3's out. So you just kind of do it 2 at a time, and you can still do the method of making them smaller. So you could like have went like this, just to show you that you'll still get, so these would be 1s. And then even though this is way over here, it's still part of a numerator and a denominator that could be canceled out. So what can these two divide by?
2.
So you could have done 1, and then 4 divided by 2 is 2. And then you'd multiply what you have left. So 1 times 1 times 1 would give you the top, which is 1. And then 2 times 1 times 5 would give you the 10. So you can still make them, you know, smaller as you go. Either way works. I'm just trying to show you that you can still use that method as you're going through there.
All right.
All right, good. So you've got that. You feeling good?
Yeah.
All right, erase the board. You're getting pretty good at that, huh? You get the hang of it? All right, let's take a look at our word problem right now. So it says, Amber has 4/5 of a pound bag of colored sand.
Okay.
So 4/5 of a pound. She uses 1/2 of the bag for an art project.
Okay. Have 1/2.
How much sand does she use?
Okay. So here I have to figure out if I'm either subtracting or dividing.
Those are the only two things you could,
Or multiplying.
or
Adding.
there you go, right? So there's always 4 options, okay? Now let's take a look at the problem one more time. It says, Amber has 4/5 of a pound bag of colored sand. She uses 1/2 of the bag for a project, and it says, how much does she use? Now, a wise guy might go half. I already said half, but we want to know what half of that is, all right? So go ahead with Cindy and work on that.
Okay.
Okay, so what are you thinking you need to do, math-wise?
I'm thinking because it says it has been used, I would say divide. But
So let's just do like a regular whole number with a similar problem. Like say, okay, if there was 8 of something and you used half of it, how much would you have used?
4.
Okay, so is that the same as dividing by 1/2 or multiplying by 1/2 or adding 1/2 or subtracting 1/2?
It's like the same thing.
Of which one? Which math?
Of multiplying.
Yeah, so this is going to be a multiply.
Okay. And then I can cross these out still. 2/1. And then 2/5 would
Yep.
be.
Nice job, you didn't add that time. Good job. And then the question was how much did they
Right, how
use?
much
So
did she use?
They used
Yeah.
2/5 of the bag.
So
Right.
2/5 of the bag.
of
There
the
you go.
sand or whatever.
And then what you can do is you can also kind of reason through it, right? If you have 4 and you used half, how much did you use?
2.
You used 2, right? So it's 2 out of the 5, right? All right, nicely done. So I think you've got the handle on multiplying fractions. All right, erase the board. If I think that you're pretty confident in multiplying fractions, what do you think is next?
Dividing them.
You are a smart young lady. All right, here we go. 4/5
Okay.
divided
there.
by 2/3. Now, my question to you is, have you done any division of fractions yet in class?
No.
Because this is what's coming up next in your book, right?
Yeah.
So that's why we're going to start working with you today on it, all right? So
Okay.
Cindy's going to help you through this.
Okay, so I wish I had a visual model for you. Okay, so multiplication and division of fractions are a little bit different. In division of fractions, you actually need to rewrite it as a multiplication problem. And how you do that is you take the reciprocal of the fraction that's after on the right side of the division. Do you know what reciprocal means?
Like that's switched.
Yeah,
And
exactly.
switch.
Good, nice. So you're going to flip over or switch to get the
Okay.
reciprocal of the second fraction, and you keep the first one exactly like it is.
So it would be 3/2.
And then you just work it out like you just did.
Okay.
So the only difference is you have to do that reciprocal first.
Or 1 1/5.
Nice. I like how you simplified it too. That's good. So if you think like, just like a visual model of why you have to do that, usually I like to hold up a piece of paper, my pencil, here we go. So if you had, say, a half a piece of paper and you divided it into 2 parts. So think of a piece of paper, right? But you only have a half of it, and you divide that half into 2 parts. So you divide it by 2, so you would end up like this. Well, how much is each part?
1/4.
Yeah, so that's why this would have been kind of the same thing. You would turn this one, you would make its reciprocal, so you would flip it over, and then you would multiply, and then you would get your 1/4. So it's like a visual way of seeing why you have to do that to that part of it.
All right.
Feeling pretty good with that problem?
Yeah, that one.
All right. Go ahead and erase the board, please.
This one.
At least she's tall.
Oh, and this.
All right, so here's another one out of your book. We'll move down a little bit. So we have 5/6
Okay.
divided by 5/12.
All right.
She's a fast learner. You got it.
All right, sweet. Here we go. Hot shot, erase the board. So now we're going to mix it up a little bit, all right? 2.5 divided by 1/6. So now you're going to have to do something before you start looking at reciprocals, all right?
Okay, so what are you gonna do first?
So I'm gonna do what some people might call I'm gonna multiply and add. So I'm gonna multiply this number by the whole number, and then I'm gonna add that with the 1 to get my answer and then I'm gonna do what you usually would do on division and switch that.
Okay, so before you go though, you're right though, but on your bottom, you put 6.
It's 6.
So on the
2.
2.5, yeah, there you go. Okay, nice. So you made it improper first, and then you did the reciprocal. Now you're just going to work it out.
Or 15.
Nice.
There you go. Nicely done, Paige. We've done a lot of problems with multiplication and division of fractions, and you seem to have grasped that pretty well. So you feeling pretty good about those?
Yes.
All right, good. Well, for your great efforts so far this afternoon, you've got yourself a meal courtesy of our friends at Broken Yoke. So congratulations on that. I was going to say something else, but we'll just let that one go by right there with all those little kicks right there. Anyway, Broken Yoke, we certainly do appreciate their sponsorship of the program. Wonderful, wonderful breakfast every time I've gone over there. And don't forget, if you would like to go to Holiday Lights at Com this year, it's not the way it's been in the past. You're going to need to drive through this year, something a little different. But if you would like a ticket for a carload of people to go through, all you need to do is give us a call. We do your problem on air, and then you've got yourself a ticket for the entire carload of people to go out to Holiday Lights. We'll be back with more right after this.
This is back where the executives sit. Passengers sit back here. we're up in the front flying the airplane, and they're here in the back, which you can tell is a pretty comfortable area.
Indeed, it is a little bit more comfortable than some other planes that I've been on.
Yeah. So basically, our passengers are back here, and they're, normally usually talking business, what they're going to do when they get to their destination, and
It's kind of like a limo in the air.
a limo in the air. That's a good way of putting it. And the privacy. The most important thing here is the fact that we have privacy. Number two is when they come out to get on the airplane, they walk out, park their car, and get on the airplane. There's no TSA, there's none of that stuff, because everybody knows everybody.
theirs.
There's no surprise. Yeah, I mean, there's not people getting on this airplane that no one knows. So we don't have to have all that stuff. And we're talking numbers again about airplanes inside here. You ask yourself, okay, we're flying along at 43,000 feet. Well, the air's pretty thin up at 43,000 feet. How do we breathe? It's based on pressurization. We take and steal air from each one of those engines as it's compressing the air, and we bring it into the cabin, and we pump this up just like if this was the inside of a balloon. And we pump it up to the point that we take the oxygen molecules that are out there. At sea level, oxygen molecules are real tight like this. And as you climb, they expand and separate, right? So as you breathe at high altitude, you're getting less oxygen molecules in. And all we're doing is bringing those molecules back together inside this space here.
And also because students that may have been on planes before, they experience that pop.
That's just your ears neutralizing that pressure, because at 43,000 feet, this cabin is at 6,000 feet. So we're breathing 6,000 feet air. Well, your eustachian tube between the back of your eardrum and the front of your eardrum has to neutralize that pressure. Otherwise, your eardrum would be like, stretching.
It's only a little bit over an inch that has to deal with.
Right, and so it stretches, and if the pressure on one side gets too high, that's when your ears feel like, oh, I got to pop my ears.
That's why people chew gum,
that's exactly right. And it's the same if you're skin diving or going down underwater. You're doing the same thing with neutralizing that pressure. So, your point being, everything we do flying this airplane has to do with numbers. Everything. If you love numbers, if you love math, tie it into something that's fun. In aviation, you can take all that numbers and, maybe kids in school might say, why do I have to learn this? Or why do I learn? And let me be honest with you. I wasn't the world's best student, okay? But I fell in love with aviation and realized that that was my passion. That's what I wanted to do. And man, did I start learning and hitting the books, because that's what I wanted to do.
And this is all math and science.
It is math and science. And when you understand, talking about weather, meteorology, and you're talking about the physics of the airplane flying, what makes it fly. You're talking about navigational skills, weight and balance, takeoff lengths, stuff like that. It's all a numbers game. Every time I take off, I do a series of numbers predicated on me losing one of those engines at the most critical time. And this airplane doesn't take off until it meets the standards to be able to lose that engine at the most critical time, and then climb at an angle of 3 degrees and clear references at the other end of the runway. We always build safety around the worst scenario. Now, how often do you lose an engine? Hardly ever. But if you
have to be ready for that.
But you have to be ready for it. And we go to training every 6 months, and we sit in a simulator, and we train, and we lose engine after engine, and all kinds of things happen. And we got engine fires and this and that. And if you make a mistake, it's no big deal, because you learn, you shut the simulator off, restart it, and you go do it again. So it's a great training tool.
Well, Steve, we certainly do appreciate your time. You ready to take a flight?
Let's go.
And I was surprised to see how many people are actually renting or booking a private plane, a private jet, for them to use instead of going on national airlines and stuff like that, bigger airplanes. A lot of people doing that right now, and that is available here in Bakersfield. And as you know, we do a lot with aviation here at Do the Math, and we certainly do love all of our aviation friends. We do have phone tutors available until 5:30 this afternoon. Time now for our friends from Science for Kern. All right, we're always up for a good challenge. And Jamie, what have we got today?
Well, today we are going to talk to Paige, and we're going to do an investigation Before we get to that investigation, just want to remind everybody, Science for Kern is a free lending library for teachers from 3rd grade to even 6th grade. And you can go on www.scienceforkern.com and choose different kits, and those individual kits can go home to students while they are either using Canvas or Google Classroom and do science at home. But today with Paige, what we're going to do is we're going to look at a science piece. We're going to learn some science terminology, and we're going to do an investigation, okay? So first thing we're going to do is we're going to look at this picture. So what I want you to do is I want you to look at the picture and tell me, what do you notice about the picture?
Well, I notice all the different colors. I notice the lumps, and I notice that only the purple one is open.
Yes.
And there's just like, it's like the same amount of steepness every lump.
Okay, so what do you notice about the people on the slide?
Well, I noticed that there's 2 in 1, and then they're on like these kind of baggy thingies. That probably helps them slide.
Okay, so this is what we're going to look at. So we've looked at the picture of the slide, and you've discussed these baggy thingies. So that's what we're going to kind of go over today. Why do you think they have those baggy thingies?
I think it helps them slide and move faster, and it won't hurt them as much if they were to like scrape themselves on these slides.
Okay, so let's look at that. So we're going to do an investigation today, and what we're going to do first is we're going to build a ramp. Now this ramp could be easily built at home. It's just out of cardboard, and I used some duct tape. So what we're going to do is you have your first one, and it's 8 inches by 11 inches. And then you have a second piece that's 6 inches by 8 inches. And then this piece right here is 2 inches by 8 inches, and I marked it off. You can kind of see at every inch all the way to 10 inches, and we know the top is 11. So what we're going to do is we're going to go ahead and build one of these together so everybody at home knows how to build one, okay? So this piece right here is the piece that's on the ground, okay? So this is our support. So what we're going to do first is we're going to take this piece, put it on here, and what you're going to do is you're going to take, we already got your tape ready for you, and you're going to put a piece of tape right in the middle of that.
All right, all the way across like
all
this?
the way across.
Won't be there, but that's fine.
There we go. So at home we have this piece, and it just hinges those two pieces together. So our next piece, and what I did is I went ahead and measured out the hole, and I already cut that for us. But those kids at home, you need to make sure that you have an adult that can help you with creating that little that hole. Now what that hole is going to do is it's going to hold this piece in there. So what we're going to do is put our measurement tool in there, and then we're going to use smaller pieces of tape to hold it on to the bottom.
So I'll go like this, and then I'll go to the other side.
There you go. And I'm going to slide this off so you can get to the other side. There you go. There we go. Now we have a ramp. So we have this ramp that we're going to use, or we have a slide, just like we see in the picture. So now, when we looked at the slide, we talked about that piece of fabric. So what we have here is we have 3 different pieces of fabric. So what I want you to do is figure out what's an investigation you can do with something with the ramp in these 3 pieces of different fabric.
Well, you can see how differently they move and how much faster it can move, or slower, or like how much smoother it would be.
Okay, so we can do that. So let's go ahead and try different pieces. So this piece right here is a fabric, it's denim. This one's called a polyester blend. And then this one right here is cotton. So those are the different types of fabric, okay, that we can use. So what do you want to do with the ramp first?
I think we'll start with cotton.
Okay, now what about the height? Do you want to change the height, or do you want to leave it?
I think we should start at 9.
You want to
9
start at 9?
inches.
Okay, let's start at 9. Go ahead.
Okay.
And then
Like
choose which one
this.
you want to start with, and then go ahead and test it out.
Just gonna put
Okay.
right there.
So when we pull them down, we're going to have that flat, and then you can go ahead and let
Oh,
it go.
okay.
There you go.
So I'm gonna have this flat.
Okay. So that's cotton. So what's
Yeah.
the next one you want to try?
This like this one.
Okay, the
Forgot
denim.
what it's called.
Okay. So what's the difference between those two so far? You see?
I feel like this one went down faster and more smooth.
Okay. Okay. You want to try the polyester?
Yes.
All right.
Okay.
What happened there?
That one slowed down a little.
Okay. So then we have those 3. Let's check it out at a different angle. What
Okay.
angle would you like to try now?
Now we can go to 10.
You want to go 10 or do you want to try lower?
Uh,
Because we know it can go down, right?
Yeah.
So let's try something maybe a little bit lower.
all right, let's go 7 then.
Okay, go for it. Oh yeah, that's all you have to do.
Okay.
All right, let's try them again.
I think I'll start with this one here.
Okay. Interesting. All right. Denim?
Mhm.
All right. Now this next one.
All right.
Okay. So what did you notice on the difference between the different heights?
I noticed that the momentum caused either one of these to go like faster and further.
Okay.
And
So let's go over some science terms. When these slide down, do you know what that's called?
like the angle part, or
No, it's
Slide.
so this piece right here, rubbing on this piece right here, is friction. Okay? So that's your terminology. So we have friction. Another thing that's happening here, there's another science term. There's a lot of science terms actually happening here, but another easy one is gravity, right? So in 5th grade, you would have already learned that gravity pulls objects toward the center of the earth, okay? But right here, we're really looking at friction because we're looking at the fabric, okay? So when we go back to this slide right here, do you think that fabric has anything to do with how fast they're going?
yes, I do, because it looks like one is it's in front of the other every time.
Okay, so we're gonna try it. Let's try it on an actual item. So I have 2 items for you. I have Mr. Rubber Ducky, Mr. Rock and Roll Rubber Ducky, and then we have Rosie Revere Engineer, okay? And then we have those same 3 pieces. So just like the picture you see, we have our little fabric swatches. So we can try them out by itself. It doesn't work too well, does it? So now you can try it with fabric. So let's see what happens when we add more mass instead of just the pieces of cardboard with the fabric over it. So let's
And
check
as
it
you
out.
start this process, you've got about 2 minutes left.
Okay, so let's try another one.
Okay.
All right, one more.
fine. Oof, I messed up on
That's
that
okay.
one.
Let's try it again. Let's start. Okay.
Okay.
Okay. So which one do you think, if you were to go down this slide, which one would you want to go down with? What type of fabric?
I actually think the cotton fit better with this one.
Yeah. Okay. So when we look back at here, we're looking at friction of fabric. So we can kind of take this to the real world. If you're going out to the playground, what type of pants or shorts are you going to wear in order to, reduce that friction? Okay. So we are finished here with our friction experiment and our investigation. You can definitely make one of these at home and try it out. And you can even make it on a larger scale with larger cars or other toys that you can try out.
There you go. Thank you very much for that. Nice to see that you can use just some scraps of cardboard and things that you've got laying around the house. You can go ahead and work on that challenge yourself and see what works best.
That's right.
All right, nicely done. And that is today's Science for Kern Challenge. We'll be back with more right after this.
It's time to explore? Yep, that's me, Onyx. I know what you're thinking. He doesn't look prepared for a day of exploring. Let's pause and think for a moment. What would you bring with you for a day hike? What items would help you be safe while exploring? Let's rewind and see how I should really prepare for a day hike to ensure my safety.
You are going on an adventure, Onyx.
You are going on an adventure, Onyx. You are going exploring. You are going exploring. How to be safe? How do I prepare? How do I prepare?
All right, once again, thank you to Science for Kern for coming down and visiting us here on Do the Math every once in a while and presenting us with those challenges and things that you can do at home as well. Don't forget, starting today, November 17th, for this week, and then after Thanksgiving for 2 more weeks, every time you phone in to do the math and we do one of your math problems on TV, you automatically get yourself a ticket to holidaylights.com, and that is for you and everybody else that you can fit legally in the car. So I figured I'd throw that out there. Anyway, so you get a whole carload of people to go to holidaylights.com for doing a math problem. Not a bad deal. All right, we have Paige in studio with us, a 6th grade student from Hart Elementary. And I forgot to ask you, have you been at Hart for a long time?
Yes, I have, since kindergarten.
Since kindergarten. All right, so you've been there for a long time. You're going to miss it next year, I think.
Yeah.
Okay, you've been there 7 years, right? What do you look forward to most in junior high? Is there anything you're looking forward to?
I'm looking forward to the different classes and the different teachers.
All right.
And definitely the PE there.
There you go. All right, so a lot to look forward to when next year comes rolling around for junior high. All right, well, let's take a look at the problem together, and you can work on it at home while Paige works on it in studio with Cindy. At a middle school, the 6th grade class of 390 increased by 10%. So 390, that's 6th grade. So I don't know if you want to put a grade level next to it or anything, or you can do it however you like. All right? And they increased by 10%.
Okay.
All right, so now 7th grade had 350 students. And they increased by 22%. And then finally, we have 8th grade.
All right.
And 8th grade had 420 students. And they increased by 20%. Now the question is, overall, what was the percentage increase of students and rounded to the nearest 10th? Now when it says round to the nearest 10th, what does that tell you already?
It's gonna be part of a decimal.
Right, there you go. All right, so you've already known that you're going to have a decimal in your answer. So you and Cindy go ahead and work on this.
Okay.
Okay, so as far as what you've done with percents, do you remember how to find the percent of a number?
I think so.
What do you think?
It's
Can you find 10% of 390 to figure out how many extra students it increased by?
it's 39.
Good. So you know the trick for 10, huh? Okay, so go ahead and write that down. Just write down next to the
Okay.
390, like how much extra students were added on.
Okay. I think I'll put 39 under that.
Okay. And so then we have 350 for the 7th grade, and that's increasing by 22%. So we want to figure out 22% of 350.
Okay.
Would you like something to make that a little easier?
Yeah.
Like a calculator?
Yeah.
There you go. All right. Do you know how to find the percent of something using a calculator?
No.
Come on over. Let's learn this right now. So we want 22% of 350. So we're going to multiply those two things, right?
Okay.
So we're going to go 350
Okay.
times. Now, how do we put 22% as a decimal?
0.22.
There you go. So put 0.22. And hit equals or enter. And what do you get?
77.
All right. So it increased by 77 students.
Okay.
Now, before you go on, I want you to think, if that makes sense. What would 10% of 350 be?
35.
And we want a little more than double 35. So 35 and 35 is 70.
Yeah.
And that's reasonable, right?
Yeah, that is.
All right. So let's go ahead and do 8th grade.
Okay, so I have 420, and I know that 10% is 42. So 20% would be about 84.
Nice. Yeah.
And I could check my answer if I wanted by dividing these.
Okay, so now the actual question is, what is the percent of change
Overall for the whole
grades?
school.
So what we need to know is, okay, well, how many students were in school before all these kids increased it? So, because you need to know what it started at and what it ended at to find the percent. So get your calculator and add up how many students.
Oh, easy. You're not
All
getting a
right,
calculator for this
I was just trying to
one.
make it take quicker, but that's fine. She can add this up.
Yeah.
You're going to add the original numbers first.
Okay, so you want me to add 390
So that we can see how many students there were.
plus 350 and 420.
Yep.
So I know that's a 0. I know that 5 plus 7 plus 9 is 16. And then I know that 3 plus 3 is 6, plus 4 is 10, plus 1 is 11. And so I started off with 1,160.
Okay. And then we also need to know how many students they ended up with once all those extra kids were added in.
Okay. So I put
So for
that-
this, I will let you use a calculator on this part.
Oh, okay.
All right.
So 39. Unless, okay, it's already at 0.
Yeah, did you clear it first?
I'm pretty sure.
Okay.
Plus 77 plus 84 is equal to 200.
Okay, so how many students are there altogether now once you add those students to the total students you had before?
There is black. What? 1,360.
Okay, so then now what we're supposed to do is figure out what's the percent. I guess technically we didn't have to add that on, but that's okay. Now that I think about it.
Right, because you
What we
figured out the
need to know
200,
is
so.
We need to know the 200 extra kids is what percent of the original amount.
Right.
That's how
Okay.
you find the percent of the overall grades, okay? So we really need to know, let's see, my pen. there we go. We need to know 200 is what percent, this is what we're really finding, of the original amount. Have you done this type of problem before?
Not really.
Not really?
That's why she's going to expand her mind today. She knows how to do percents and things like that, but this is the next step.
Okay, so there's different ways. I prefer proportions. I don't know. Do you use proportions, Mr. Kushine?
Yes,
Okay.
but I don't know if Paige does in a regular classroom.
Have you ever done a proportion?
Ratios and proportions?
Ratios, yes.
Okay.
Okay. Yeah, I didn't think of that. You might not do it that way in 6th grade. You might do it in equation way. All right.
So she could just do 200 over 1160
Yeah.
and do it that way.
Yeah, exactly. Because that's what you end up doing is 200 out of 1160 is what percent, which really means out of 100.
Right. So for this, I'll allow a calculator also.
Oh, okay.
All right. So you're going to do
So this
200.
is really the part you need to, 200 over 1160. Do you know how to calculate that percentage? Like if you got a grade, the top number over the bottom number, do you know what to do with them to get the percent?
No.
No? Okay. So without the proportion part of it, just with that part, you divide the top by the bottom.
So just go 200.
All right.
And then that fraction lines means divided by. So you're going to divide and then divide by that bottom number.
Well, 0.1724.
Okay,
I only need to know the hundredths because I'm rounding it to the tenths.
Okay, but hold on, because you actually have to make it a percent first. Right now it's a decimal. So you have to make it a percent. You know how you made the 22, or the, 22%, 0.22? You want to make that a percent now.
Okay.
So what did you get?
I got 0.1724137993.
1724, give me one more.
13793.
All right. So to make it a percent, you either multiply it by 100, which is the same as moving the decimal twice to the right.
Yeah.
So what will that be?
So that would be 17.241.
And then you need to round it to the tenths. So what would you round it to, or what would you
So I would round that. I would keep it 17.2 because of the 4 and the hundredths is less than 5.
Good.
Good. Nicely done. So it's 17.2% increase. All right. Nicely done. Erase the board, young lady. Time for your final activity.
Okay. Okay,
Whoa.
well.
You eliminated the board instead of erased the board.
Push the
That's okay.
square.
Here, you know what? I'll help
Instead
you.
of touch screen because
There we go.
I don't know where I was at, but whatever.
So there you go. Yeah, just don't go outside of it.
Okay.
There you go.
Okay. Wait. It's not working. Okay.
Just leave it. We're not even going to use it anyway.
Okay.
All right, so go ahead and put the pen down. Come on over here, Paige. So here's what we're going to do right now, all right?
Okay.
So take a look at these. These are 5 different sets of Legos.
Yeah.
What do you notice about them?
That they're all making up the same amount as that.
And how many is that?
That's 8 total if you were counting the little dot.
Right, okay, so that's 1 whole of 8, okay? Now, if that's 1 whole, okay, we're gonna count that as 1. What would these 2 pieces be?
1/2.
They would be 1/2, right? So explain to me some other things that you see here also.
Well, these 2 would also be 1/2 because they technically represent the same amount, just in a different shape.
Right, so that is 1/2 each of those, right? But in a different array, right? They're set up a little differently,
Yeah.
all right? What do you notice about these?
They're split into 4 different things, so they would be 1/4 each.
Perfect. And what about these?
Also, 8 different things now, so they would be 1/8.
So they would be 1/8, right? But all of these are different ways to represent 1 whole, which consists of 8.
Yes.
We agree on that? All right. So here's what you're going to do. We've got some different Lego pieces here.
Okay.
And what I'd like you to do is, how many different ways do you think there are to make 8 besides the way I've done? How many different ways do you think there are?
Many, but not that I know.
Well, here's a clue. How many of these are there?
There's 8 of them.
1, 2, 3, 4, 5, 6, 7, 8. So there's 8 more ways to represent 8. So take any one of these
Okay.
All right, put it down there, anyone you
Okay.
want. All right, now using these pieces, represent 8 again, and explain to me the pieces you're using.
Okay. I think I'm gonna use this one, and then I'm gonna use this, and then I'm gonna use this, because this is like 1/2, but these two would also equal 1/2, which can equal to a whole.
Perfect. So you have 1/2 plus,
2/4, or another half.
okay, so you've got, so here's what I want you to do. So we have 1/2, and what's this?
1/4.
And that is?
1/4.
All right, perfect. So here's what we're going to do. We're going to write these up on the board. So I'm going to show you how to
okay.
get rid of this stuff real quick. We're just going to go like that. All right?
Okay.
So what I'd like you to do is up on the board, write down what this is.
Okay, like in addition or just like one whole?
Addition. So you've got 1/2, right? So you're going to go 1/2.
1/2 plus 1/4 plus 1/4.
Good. All right. So come on over, grab another base, right? So
Okay.
that's 1. That's done. You can't do that one again.
Okay.
So now find another way to make 8.
Okay. I think I'm gonna use this third, and then I'm actually gonna take 2 of these.
Okay.
So-
Now you said that was a third, but what are
Or
we going to call
3/4.
3/4? All right. Or, okay, so we're going to put 3/4, right? So we've got another problem now, right?
Yeah. 3/4.
Plus what else? What else did you add?
I added these 1/8.
Okay, so go ahead and put 1/8 plus 1/8, right? All right.
All right.
So that one's done. You think you can find another way quickly?
Yes.
All right, grab a base and try it again.
I think I'm gonna go here, here, and then I'm actually gonna grab these 2.
All right, so
right.
right up on the board. You can bring it up there if you want to look at it.
I don't need to.
Okay,
I'll go 1/2
good,
plus I did 1/4
perfect,
plus 1/8 plus 1/8.
good. All right, you did that pretty quick. You think you can get one more?
Yeah.
There you go. All right, let's go. Let's see if we can get one
Okay.
more.
I'm gonna do this one. I'm actually gonna do this one, and then I'm gonna do that one.
Very good. All right, so just tell me what it is quickly.
All right, this is 1/2 plus 1/4 plus probably what I already did plus 1/8 plus 1/8.
That's okay, because you used a different 1/2, right?
Oh, yeah.
So it is technically a little different right there. So I've got 2 questions for you. Did you learn a little something today on Do the Math?
I did actually.
Good. So and the second question is, did you have some fun?
Yes, it was fun, and I was really happy to do it.
Good. Well, I'm glad you were able to come and visit us today, and glad you had some fun and learned something. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.